This problem is very similar to the first one, except each of the two denominators is different. So we're going to start by identifying the common denominator because there's no need to factor. The denominators are quite simple. So the common denominator is actually x squared minus 1 because that's the product of x plus 1 and x minus 1. But sometimes it's easier to see if you go ahead and write it in its factored form. So x plus 1, x minus 1, and x plus 1, x minus 1. Now, for clarity's sake, I'm going to go ahead and write the fact that I would simplify this to be 5 times x squared minus 1 on this side, so then I can distribute it to 5x squared minus 5. Now, on the other side, when I multiply that common denominator by the first fraction, the x plus 1's cancel, and it's just 5 times x minus 1. Whereas when I multiply that common denominator by the second fraction, it's the x minus 1's that cancel, and I'm adding x times x plus 1. So I can do those two distributions and get 5x minus 5 plus x squared plus x. Now, this looks like it's going to be a quadratic equation, so we're going to get everything on one side of the equal sign. Just because I have positive x squareds over here, I'm going to go to that side. So subtracting the x squared, I have 4x squareds. Here I have an x and a 5x, so that's 6x, so negative 6x. And then when I add that 5, the 5's will actually cancel. So I just have that, 4x squared minus 6x. I can factor out the 2x that they have in common, leaving behind a 2x minus 3. So I can see that my two solutions would be x equals 0 or x equals 3 halves if I set that 2x minus 3 equal to 0 and solved. Looking back at the original problem, plugging in 0 for the denominators will not cause a problem. It won't make a denominator equal to 0. Same is true for plugging in 3 halves. Neither of those would make the denominator equal to 0. So those are both solutions. We have no extraneous solutions to this problem.